In this video, I will solve one question regarding the discrete time Fourier transform in which I am giving you h of n as alpha to the power n un, and the input x of n is equal to b to the power n u of n, and the output is y of n, and x of n and h of n are given to me, and I'm trying to find out what the frequency transform, Fourier transform of y of n. Okay, that's the question here. So how should I approach to this problem? Again, y e to the power j omega is equal to x e to the power j omega times h e to the power j omega, and this is the convolution property, if you remember. Okay, convolution property. So what does convolution property mean? If I have the input x of n and my impulse response y of n, I should take the convolution of the two in order to obtain the output signal. The Fourier transform correspondence of this is equal to y of e to the power j omega is equal to the multiplication of the Fourier transform of the input and the impulse response. So that's why I should go with this Fourier transforms immediately. So I should find x e to the j omega, and beta of n un, the Fourier transform of this is equal to 1 minus beta e to the power minus j omega, and h e to the j omega is equal to 1 over 1 minus alpha e to the power j omega. Okay, so what should I do? Y e to the power j omega is equal to 1 over 1 minus beta e to the power j omega times 1 over 1 minus alpha e to the power j omega. So this is how I should approach to this problem, and now I should go with this, arkadaşlar. Now what should I do? I should change this multiplication into this form. You see, a times this plus b times this divided by the multiplication should be equal to 1 divided by 1 minus beta e to the power j omega times 1 minus alpha e to the power minus j omega. So if I find a and b, I can directly come back to the original y of n, okay? And I will try to give you how we are doing this. First, I should multiply a times 1 minus alpha e to the power j omega plus b times 1 minus beta e to the power minus j omega is equal to 1. The denominators are already equal to each other. That's why I don't do anything. A plus b is equal to 1, right? A plus b is equal to 1. Alpha a minus beta b e to the power j omega is equal to 0 times e to the power minus j omega, right? So this part should go away. So I have two equations, two unknowns. A plus b is equal to 1. Alpha a minus beta b is equal to 0. So what should I do? I should multiply I'm sorry, I should change something here. A times minus a times alpha, and then minus b times beta. So this minus should be over here. That's why this minus will go away, because this is already 0. Inside should be 0. Okay, so again, a times minus a times alpha e to the power minus j omega minus beta b e to the power minus j omega. So this minuses will appear here, and then alpha a and beta b will appear in this parentheses, and this one will be there. So the coefficient of e to the power minus j omega is going to be 0. That's why I should come here. Then I'm going to write a is equal to 1 minus b, and I'm going to write alpha times 1 minus b plus beta times b is equal to 0. And then alpha minus b, alpha minus beta is going to be equal to 0. So b is going to be equal to alpha over alpha minus beta is equal to 1 minus alpha over alpha minus beta, which is minus b divided by alpha minus beta. Okay, alpha minus beta minus alpha, alphas will go away, and I will have only minus b over alpha minus beta, minus beta divided by alpha minus beta. Okay, so we found a and b here. Then finally I will have my y e to the j omega, which is equal to, where was b? B is in the alpha and a is in the beta part. So I should write minus b divided by alpha minus beta, 1 minus alpha e to the power, beta e to the power minus j omega, minus plus alpha over alpha minus beta divided by 1 minus alpha e to the power minus j omega. Okay, I hope this part is clear, arkadaşlar. Let me write this beta here, and then this is y e to the j omega. If I want to go back to y of n, this coefficient will be b over alpha minus b, and beta to the power n un is my inverse Fourier transform, plus alpha over alpha minus beta, alpha to the power n un. Okay, this is the Fourier transform of the output, and this is the output itself in time domain. I hope you got the main idea. If we go back and look at the question again, I have given you alpha and beta in the question, and I wanted you to find the y e to the power j omega. I started by converting x of n to x e to the power j omega, h of n to h e to the power j omega, and then I found y by using the Fourier transform of x and h, and then I found a and b in order to determine y of n from y e to the power j omega. Okay, so if you again look at what was h of n, arkadaşlar, h of n was here, and it is alpha n un, alpha to the power n u of n, and alpha is given as this. So is this system stable? Yes, it is, because alpha will either be like this, so it is stable. The addition of this function alpha n from 0 to infinity will be equal to 1 minus 1 over alpha, and it will be like a finite value. Okay, and then otherwise it's like this one. So it's again, alpha is going to be n is equal to 0 to n, and alpha is like minus 1 over 2, for example, to the power n, 1 over 1 plus 1 over 2, which is 2 over 3. Okay, if alpha is plus 1 over 2, then it will be 2. So again, finite. So this is a stable system. This system is stable. Is this causal? Yes, because it's starting from 0 and going onwards. There is nothing on the negative side. So it is a causal system. Okay, arkadaşlar, I hope this is clear on your side. And this is all for this example. And I will go and solve another example in the next video.